Alrighty, mathletes. It's time to start putting everything that we've been learning together. So today we're going to start talking about finding roots given roots, which means we're going to be using sort of the rational root theorem and then definitely using the remainder and the factor theorem. Okay, so it's going to come at us like a 1, 2, 3 punch. So first, the rational root theorem gives us a list of possibilities. I'm going to go ahead and tell you for today, we don't really need a list of possibilities. We're just throwing you a bone. But later, we're not going to give you these hints right off the get-go, but you can use the rational root theorem and also your graphing calculator to come up with a list of possible rational roots. Then we can use the remainder theorem to prove where the zeros actually are. And then once we know where the zeros are, we also can use the factor theorem, because if it's 0, we know it could be a linear factor. Ergo, that will allow us to break down a larger polynomial. So this is kind of a shortened version of how we're going to be solving higher degree polynomials. Okay, so we're going to go through and we're going to take a look at 3 quick examples. Okay, so these are generally categorized as finding roots given roots. Okay, now you could have been given roots by the rational root theorem. You could have been given roots by looking at your calculator. But for these problems, you're going to be literally given the roots. We're just telling you what one of them is. Okay, so example 1 here says that 1, 0 of f of x is x equals -5. -5. Now we need to find all the zeros of f of x, which equals x cubed plus 6x squared plus 3x minus 10. All right, so first off, if we know that 1, 0 is -5, I can go ahead and evaluate the function using synthetic substitution, aka division. Okay, remember remainder factor theorem, all that other good stuff. And I can go through and do that against x cubed plus 6x squared plus 3x minus 10. So 3, 2, 1, none are my exponents. It's in standard form. And I can just go with a 1, a 6, a 3, and a -10. And because I know it's a 0, I know I'm going to get a 0 here. All right, so start by copying down the 1. -5 times 1 is -5. 6 minus 5 is 1. -5 times 1 is -5. 3 minus 5 is -2. And -5 times -2 is positive 10. So what does all this mean? Well, it means that I could factor it. Okay, where I could say that f of x equals my given factor, which pulled out of this, remember, would be x plus 5. Okay, so I've got x plus 5 is one of my factors. And then the other one comes from what was left over when I did my synthetic division with a remainder of 0. That's got to be the other factor. So that's x squared plus x minus 2. Okay, but then we could keep factoring and we'd end up with x plus 5. And then this quadratic trinomial with a leading coefficient of 1 would factor into x and x. And what are factors of -2 that add up to positive 1? Well, plus 2 and minus 1. Okay, but it says find all the zeros, so we need to go one step further than that. And if we're going to go one step further than that, we need to solve each one of these factors, because then we're using what's called the zero product property. So I'm going to get one solution that's -5, which shouldn't come as a surprise because they literally told me one of my answers was -5. But what are the other ones? Well, I'm also going to get x equals -2, and then I'm also going to get x equals a positive 1. Okay, if I set these factors equal to 0, that's where the -2 and the positive 1 would come from. All right, so if I needed to go and write out my zeros from smallest to largest, okay, I would say the smallest one is -5, the one in the middle is -2, and the largest one is a positive 1. So this represents my solution set for this polynomial function. Okay. Earlier in the unit, we mentioned what's called the fundamental theorem of algebra, And I want you to take note that the fundamental theorem of algebra is still holding here. We started off with a cubic function, and how many solutions did we find? One, two, three. Okay, so all of these are real numbers. All of these are rational numbers. All of these would have come from the list of possible rational roots using 10 and 1 as your values for P and Q. Okay, so essentially all we've done is extended the idea that once we have something written in totally factored form, we can also go and find the solutions for each one of the factors, and therefore we have a solution set for the entire polynomial. Easy peasy, lemon squeezy. All right, let's take a look at another one. Ooh, this one says two zeros of g of x are x equals -1 and x equals -2. Find all the zeros of g of x, which equals 4x to the fourth plus 12x cubed plus 9x squared plus 3x plus 2. Okay, so ultimately my answer is going to end up being x equals and some set of values that I need to go and plug it in. Okay, but before I can do that, I need to go and think, how can I use the bits of information that have already been given to me? Okay, well, I've already been told that x equals -1 is a 0 and x equals -2 is a 0. So because I've been given two zeros, I'm going to have to do division twice. Okay, the order that I do it in doesn't particularly matter, but since x equals -1 was written first, I'll go ahead and do -1 first. Okay, so -1 is going to be my synthetic divisor. And because this polynomial g of x has exponents of 4, 3, 2, 1, none, it's written in standard form, so it's all ready to go. So I've got 4, 12, 9, 3, and 2 are all of the coefficients there. Because it told me it's a 0, I know it's going to have a remainder of 0. So, doing a little bit of arithmetic, copy that 4 down. So -1 times 4 is -4. 12 minus 4 is 8. -1 times 8 is -8. 9 minus 8 is 1. -1 times 1 is -1. 3 minus 1 is 2. And -1 times 2, yep, gives me -2. So I do, in fact, have a remainder of 0. So at this point, what I could do is I could write it as x plus 1 as one of the factors, which of course came from this solution, okay? And then I could multiply that by 4x cubed plus 8x squared plus x plus 2, okay? But then what do I do with this other one? Well, here's the thing. You just keep dividing, okay? But don't start over all over again. There's no point in doing that. Do another level of synthetic division right here, okay? You can do that, okay? If you have the number like, say, 12, okay? Factors of 12 include the numbers 3 and 4. So if you take 12 and divide it by 4, you get a quotient. Is that quotient still divisible by 3? Uh-huh. If you had 12 and you divided it by 3, is that quotient still divisible by 4? Uh-huh. So you can just keep doing the division, and I'll explain why in a minute, okay? So our second given 0 was -2. So I'm just going to use the quotient from my first division to go ahead and do my synthetic division. It's going to be great, okay? So if I'm doing synthetic division, I need to copy down that first term. So 4 just gets copied down again. -2 times 4 is -8. 8 minus 8 is 0. -2 times 0 is 0. 1 plus 0 is 1. And -2 times 1 is, wow, amazing, -2, which gives me, yet again, another remainder of 0. So what does this all mean right here? Okay, well, if I stopped doing what I was doing in red, I could factor it like this, but this isn't really that easy to go and solve. It is solvable, but it's not easy and it's not pretty. This is actually beautiful, okay? You don't know it yet, okay? It's ugly duckling math right over here, but this is about to turn into a beautiful swan. Because are you ready for this? All of this means that g of x, which I'll actually go through and try and write in a more neutral color because I want you guys to be able to see where everything's coming from. All right, so g of x, okay, which of course equals 4x to the fourth plus 12x cubed plus blah, 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 okay, it equals all that stuff. But it also equals, you ready for this? X plus 1 is one factor that came from this given 0. X plus 2, which is another factor that came from our other given 0. And the other piece that's here is just 4x squared plus 1. Okay? So this g of x quartic polynomial function has been factored into a linear function times a linear function times a quadratic function. And if we want to find all the zeros, what do we do to those? We set it equal to 0. So I already know what two zeros are going to be, right? I know that I'm going to have a -1 and a -2. So I'm just going to go ahead and write those in the order that they are now. And if I need to rearrange it, I can. So I know that x is equal to -2 and it's also equal to -1. That was given to me and I verified it using synthetic division, the remainder in the factor theorem. Okay, but what I still have left to do is I still need to go and solve this green guy here. So I need to set 4x squared plus 1 to be equal to 0. Well, you should look at this and recognize that it only has a quadratic term. And because of that, we should solve it by taking square roots. So we're going to start by taking 1 away from each side. So I'm going to get 4x squared equals -1. Then I can go and divide both sides by 4 because I want to get the x squared all by itself, right? So that's going to turn into x squared equals -1/4. And then I'm going to take the square root of each side and I'm going to get x equals plus or minus the square root of -1/4, which hopefully you remember from the beginning of the year, there's some things I need to do here, okay? So this is really going to turn into x equals still plus or minus. There was a negative sign under the radical. So that means it needs to include the number I. Okay, remembering that I is really the square root of -1. Also, if we have the square root of -1/4, it's really the square root of -1 times the 1/4. Okay, but the square root of 1/4 is really the square root of 1 of the square root of 4, which is really simplified to 1/2. Okay, because again, just making a note over here, friendly reminder, square root of 1 over 4 using the quotient property is really √1 over √4. So that's where you're getting your 1 and your 2 from, okay? But I would want to write the 1/2 as the coefficient to the I. So when I go up and put it in my actual answer list, I'm going to say that the other solution that I have here is plus or minus 1/2 I. Okay, and that is going to represent my actual solution set. Okay, so we did synthetic division not once, but twice because we were given not one, but two zeros. Okay, so thinking back also to the fundamental theorem of algebra, this was a fourth degree polynomial. So how many solutions should I get? Well, I should get 4. And I have 1, 2, and then the plus minus is really 3, 4. Okay, so it looks a little ugly, but like I said, it's ugly duckling. Okay, it looks ugly, but what is it really? A beautiful, majestic swan. Embrace swan math. It's good for you, builds character. All right, so when you're given 2, you just do synthetic division twice to write it in factored form so that you can solve for each one of the factors. And you kind of get a little get out of jail free card because a lot of times at least one of those has already been solved for you. Okay, so let's go through and take a look at one more. Example 3 says 1, 0 of the function h of x is that x equals 3. Find all the zeros of h of x equals h cubed minus 7x squared plus 10x plus 6. All right, so let's get to work. So we know that h of x is this cubic polynomial function. We also know that it has a 0 at 3. So let's get started. Let's use that. Okay, so if it's got a 0 at 3, I know that if I evaluate the function at 3 or divide it by x minus 3, then I'm going to get a remainder of 0. Well, what am I dividing it by or evaluating it for? Well, 1x cubed minus 7x squared plus 10x plus 6. Okay, and I know I'm going to get a 0 there. So if I go and do the math, copy down the 1. So 3 times 1 is 3, negative 7 and 3 is negative 4, 3 times negative 4 is negative 12, 10 minus 12 is negative 2, 3 times negative 2 is negative 6, and voila, I do get a 0. Happy days. So what does this mean? This means that I can write h of x as being equivalent to the pseudo-given factor of x minus 3, and then the leftover part, which is going to be 1x squared minus 4x and then minus 2. Okay, so I'm trying to go through and find all the zeros. So what do I need to set this equal to? Well, 0. Do I already know what the first one is? Yeah, because it was kind of given to me. So I'm just going to go ahead and put the 3 there, and then we're going to have to figure out what the other part is. So I need to solve this. This is a quadratic. Okay, it's a trinomial because it's got 3 terms and it has a leading coefficient of 1. But there aren't any factors of negative 2 that add up to negative 4. So it's not factorable, but that doesn't mean it's not solvable. How could I solve it? Using your favorite thing in the whole wide world. Okay, you get so happy about doing it that you sing songs every time you get to. Okay, negative b, negative b. No, stop it. Okay, enough with the singing. Let's just like actually use our brains. So if we've got a, b, and c, we have a, b, and c. Looks like it's quadratic formula time. So the leading coefficient a is 1. Our middle coefficient is negative 4. And our constant is negative 2. So applying those, negative b is really the opposite of b. So it's really positive 4 plus or minus the square root. Negative 4 squared is 16. Remember, do that in your head, not a calculator. Minus 4 times a, which is 1, times c, which is negative 2. And all of that is divided by 2 times a, which is 1. Okay, so this is really 4 plus or minus, and let's do a little mental math. 4 times 1 is 4, times negative 2 is negative 8. 16 minus negative 8 is really 16 plus 8, which is just 24. Okay, so 4 plus or minus the square root of 24 all over 2. But surely this can be simplified, okay? And I believe that it can. So if we go, and side note goat over here, think about the square root of 24. What are its perfect square factors? Well, 4 and then 6. Okay, so the square root of 4 times the square root of 6 will equal the square root of 24. But what is the square root of 4? It's 2. So 2 times the square root of 6 is the same thing as the square root of 24. So this is going to be 4 plus or minus 2 root 6 all over 2. But I got to remember that I can kind of go through and simplify this out a little bit because I have a common factor in the numerator of 2 that will eliminate the factor in the denominator. Or I think it's easier to write it as 4 over 2 plus or minus 2 root 6 over 2. And then these guys get in like an epic ninja battle, and that reduces to 2. Sorry, that's not a 6. That's just another 2. Doy. So back to the ninja battle. Boom, boom, those are all gone. So what's the only piece that's really left over? Well, you got a 2, and you got plus or minus a square root of 6. Okay, so if we go take a look at that one, our solutions that we found were 3, the one that was given, and then we have 2 plus or minus the square root of 6. okay, which that to me looks like the definition of an irrational number. So I'm definitely not going to find that in the rational root theorem. But what other theorem am I going to go through and check at the end? Probably the fundamental theorem of algebra, where I say this is a polynomial with a degree of 3, and how many solutions does it have? 1, 2, 3. Okay, so essentially all we've done in addition to yesterday is start solving all of the factors that we've generated by using the remainder theorem and the factor theorem to factor down the polynomial. If you're given 1 0, just do synthetic division once. If you're given 2 zeros, do synthetic division twice. You may hear me refer to this as stacking synthetic division. Okay, it just makes it where you can actually make it smaller and write it as the product of smaller factors instead of just different factors. Okay, so as long as you guys are comfortable with being able to solve linear equations and quadratic equations, the rest of this should be a piece of cake.